Greetings to all dear learners. I am faculty of physics at SRN International School, Jagatpura, Jaipur. Today we will learn some topics of alternating current, which is taken from chapter 7, grade 12th physics. Today I will cover few topics of alternating current, and the topics are alternating EMF and current, average or mean value of alternating EMF and current, root mean square value of alternating EMF and current. So let's start with alternating EMF and alternating current. So the word alternating means the value of EMF and current varies alternating in positive half cycle and negative half cycle with respect to time. Here in the graph we can express the same thing. In the first graph we will find that the value of alternating EMF is given as E0 sin omega t, and the value of current is represented as I0 sin omega t. It means the first graph is a sinusoidal graph, and second graph we will find EMF is equal to E0 cos omega t and I is equal to I0 cos omega t. Here it is a cosine graph. So if we find the value of sin omega t as 0, so our EMF and current will start from 0. When it will cover a phase angle of pi by 2, that if we put the value of omega t as pi by 2 phase angle, we will get sin 90 is 1. So we will get the maximum value of EMF and maximum value of current. So here in this graph we will find that graph starts from 0, reaches to the maximum point. E0 and I0 represents the peak values of current and EMF respectively. Then it will come again to 0. And similarly this graph will show the value of current and EMF. Now coming to the second graph, we will find that if the value of cosine of omega t is 0, it will give you the maximum value of EMF and current. So the graph starts from the maximum value of EMF and current, and it reaches to 0 at cos 90 is equal to 0. So at 90 degree phase angle, current and EMF both becomes 0. Then this graph continues and complete its respective cycles. Now let's talk about next topic, that is average or mean value of alternating current. As we have seen in the previous curves that current and EMF value changes alternatively, it means it will cover first positive half cycle and then negative half cycles. So we need to find an average value or mean value of alternating current. So to find the value of current, we can get the idea from the charge. dq is the charge, is given as product of current and time. So dq is equal to I dt, which is further represented in terms of instantaneous value, that is I0 sin omega t dt. Now after integrating both the sides, we can get the value of charge. So charge is given as integration of I0 sin omega t dt, and the integration limit will be from 0 to t by 2. This t by 2 represents the average value of time from 0 to t, that is t plus 0 upon 2, it will give you t by 2. Now further after integrating, we will get q is equal to I0 t upon pi, and here we will get the average value of alternating current, that is I average is equal to q upon t by 2. Now if we get the value of reciprocal, we will get the exact value of mean value or average value of current. So I mean or I average is equal to 0.637 I naught. In percentage we can write 63.7 percentage of I naught. It means that the average value of current in alternating current will be 63.7 percentage of peak value of current in the circuit. Now let's talk about the root mean square or virtual or effective value of alternating current. As we know that the value of current in alternating current keeps on changing with respect to time. As time changes, the value of current also changes. First it moves in the positive half cycle, then it moves in negative half cycle. So value is not fixed, it is keep on changing. And we don't have a particular value at a particular series of timings. So to get a specific or effective value, we can have the root mean square value of current. Now, according to the concept of the current, we can have the same work done applied by direct current and alternating current, and the value which we are going to get will be the value of current. So effective value can be calculated with the help of the work done from Joule's law of heating. So according to that, heat is equal to I square R dt. Now for a small value of heat, we can write dH is equal to I square R dt, which can be written in terms of instantaneous current, that is I naught square R sin square omega t dt. Now after integrating, we can have the value of heat, that is H is equal to I square RT upon 2. Now we can replace the value of I square upon 2 with virtual value of current, that is IV. So H is equal to IV square RT. Now it means that IV is equal to I naught upon root 2. That is the effective value of current. So we can calculate the accurate value of effective current as 0.707 I naught. In percentage we can write 70.7% of I naught. It means virtual value, RMS value or effective value of alternating current is equal to 70.7% of the peak value of current in the circuit. As we obtain values of average current and RMS current, similarly we can get this value for the mean value of EMF and virtual value of EMF. So significantly we can write average value of EMF is equal to 0.637 times of the peak value of EMF, and also the virtual value of EMF or RMS value or effective value of EMF can be written as E is equal to 0.707 multiplied by peak value of EMF. So we can write simply as per the analogous to the current. If it is not mentioned specifically about the nature of current or EMF in the circuit, it will be generally the virtual value of EMF or current. For example, if it is written 230 volt AC, it means that 230 volt of RMS value of EMF. So that's all for the first part of alternating current video. I hope you must enjoy this video. This video is very informative. Now thank you all of you for listening me carefully. Like my video, also subscribe our YouTube channel. Thank you. Bless you kids.